Welcome everyone. Today we will learn about probability distributions. So far we have learned what is probability and how the different types of probability like conditional probability, normal probability, different types of events like mutually exclusive events, independent events, etc. So today we will learn about how we can identify the pattern of probability. So if we have to learn about probability distribution, first we should know what is a probability distribution. So the way in which the total probability 1 is divided into different possible outcomes lead to different patterns of probability. Now here you should know that the total probability, that is 1. Now 1 means, we already discussed that what does 1 means in terms of probability. It is certain, right? So in case of tossing a coin, suppose there are two outcomes, one is head, one is tail. So under normal situation the probability of head is half and the probability of getting a tail is also half. So see, if you add both of them you will get 1. Right? So in case of a die, the outcomes are 1, 2, 3, 4, 5 and 6, right? And if everything is fair in that die, every outcome has a probability of 1 by 6, 1 by 6, 1 by 6, 1 by 6, 1 by 6 and 1 by 6. Now if I add all of them, this is called total probability. If I add the probability of every possible outcomes of an experiment, these are outcomes of an experiment called tossing a coin. These are outcomes of an experiment called throwing a die or rolling a die, right? Now if I add the probability of each and every individual outcomes, I must get 1. Here also if I add, I will get 1, right? Similarly for every card, the probability is 1 by 52, right? Because there are 52 cards and there is only one card. Every card is unique, so the favorable case will be 1. So in that case, every card from a pack of cards has a probability of drawing 1 upon 52. And if I add such probabilities, there will be 52 such probabilities, right? 52, so it will lead us to 1. So this is called as total probability, right? Now in these three examples of coin, die or playing cards, we see that every possible outcome, whether it is a head or tail or these numbers 1 to 6 or these cards like hearts, 8 of hearts or 7 of spade, etc., etc., everyone has the same exact probability, right? But in real situation the case may not be. Whenever we are playing Ludo, we don't see 6 very often, right? We see lower numbers very often. Say for example, in a die some numbers has high probability compared to some other numbers, right? So that is called that that means that in general or in real life situations, every outcome of an experiment will not have equal probabilities. Let's take the example of testing for a disease. Right now let's say testing for COVID-19. If you have an history of being in touch with someone who is recently been positive, your probability of getting the result as positive is high compared to negative, right? So in such a case the probability of positive will be high compared to negative and we are not getting equal probabilities. That means in real life situation outcomes are not necessarily equally likely, right? And if you add all the probabilities of the possible outcomes, you must get a value which is equal to 1. Now how you divide this 1 leads to different types of probability distributions, right? So imagine you are dividing a, let's say, pizza, right? there are 8 friends, right? There are 8 friends and they order a pizza. So the person will divide it diagonally, right? Because this gives us the most uniform division. So if you cut your pizza into 8 pieces like this, right, this way, you are getting equal proportions, right? This proportion, everyone is equally divided. Everything is equally divided. So this is one way of dividing the pizza. But if you divide a pizza, or if you cut the pizza like this, right? So if you cut using some vertical lines, right? Here also we are dividing it into 8 different parts. Now when you cut, you see this part, this extreme parts, extreme left and extreme right parts are less compared to their right side or left side parts, and the most middle parts, that means this and this, has the maximum share, right? So the person who is getting these 2 cuts will be more beneficial. The extreme cuts are low in size, right? So here the cuts are not uniform, right? They are not equal for all of them. So this is another way of dividing the same pizza. So how you divide the pizza will lead to different types of probability, right? How you divide the value 1, because total probability is always 1. How you divide this total probability 1 into your different outcomes will lead to different types of probability distribution. So there are 3 standard distributions that we study the most. Number 1 is binomial, number 2 is Poisson, and number 3 is normal. Now before discussing about these 3 distributions, there are some prerequisites that you should know. First of all, types of random variable. Random variable. So what is a variable? A quantity that is not fixed, that keeps on changing, is called a variable. Now if you cannot predict the value of a variable, right, then it is called a random variable, just like a random experiment. So the outcome, that basically in simple words, the outcome of a random experiment is called a random variable. That's the simplest definition I can think of right now, that the outcome of a random experiment is called a random variable. So there are 2 types of random variable. Random variables are of 2 types. One is called discrete and one is called continuous. So we have a discrete random variable and we have a continuous random variable. So what are the examples? So when you toss a coin, there are 2 distinct values, right? Head and tail. So that will be a discrete random variable. Similarly, when you throw a die, there are 6 different outcomes, 1 to up to 6. So they are very distinct from each other. So that will be a discrete random variable, right? So that means outcome of tossing a coin is a discrete random variable. Outcome of throwing a die is a discrete random variable. But imagine a situation where you are dealing with temperature. The temperature of an experiment may lie or may be anything within a permittable limit, right? Suppose a particular experiment, a chemical experiment, produces a heat within the range 25 degrees centigrade to 85 degrees centigrade, but the exact value of that experiment is not known before conducting the experiment, right? We cannot predict what will be the exact value of the temperature, but we certainly know that the value will lie within 25 and 85 degrees centigrade, right, or Celsius. So this is an example of continuous random variable. So the outcome of such an experiment will be called a continuous random variable, because the value will lie anywhere, can have the possibility of lying anywhere, and you cannot distinguish the possibilities as a discrete case, right? Just like in case of head or tail or 1 to up to 6 or the 25 different distinct card in a pack of card, in here we cannot distinguish the possible outcomes. It can be 28.1 also, it can be 28.01 also, it can be 28.0001 also. So you cannot get a distinct value, right? A set of distinct values. So that is called continuous random variable. So this binomial distribution and Poisson distribution are related to discrete random variable, right? So the probability pattern of discrete random variable leads to binomial distribution and Poisson distribution, whereas this normal distribution is related to continuous distribution, right? So in our syllabus or in this lecture, we are going to learn about 2 discrete distributions and 1 continuous distribution. This difference between binomial, Poisson and normal is very important, because the way the distributions are, that is whether it is discrete or continuous, the calculations also depend, and calculation also varies, right? So let's start with binomial distribution. Now what is binomial distribution? So imagine there is an experiment where there is only 2 possibilities, right? One is called success and another is called failure, right? So you have 2 possible outcomes, either success or failure, and both of them obviously cannot occur at the same time. A person cannot succeed and fail at the same time. So obviously these 2 outcomes are mutually exclusive. So when 2 events or 2 outcomes cannot occur simultaneously, they are called mutually exclusive. So imagine a situation where you have 2 possible outcomes, either success or failure, and they are mutually exclusive. Then such kind of experiment are called Bernoulli trials or Bernoulli experiments, right? So those are called Bernoulli trials. Now if you combine multiple Bernoulli trials, that gives you a binomial distribution, right? So let's take the example of tossing a coin, right? So tossing a coin leads to head and tail, right? So there are 2 possible outcomes, heads and tail. Suppose head means success, right? So for us, if I get a head, I will be successful, and if I get a tail, I will fail, right? So for me, head is the event of interest. So this experiment or tossing a coin will be a Bernoulli experiment, right? Now if I toss multiple times, if I repeat the experiment multiple times, right? So suppose I have tossed 4 different types, right? I have tossed the same coin 4 different times. So every toss can lead to either success or failure, right? Let's say I have succeeded, that means I got a head in my very first toss, right? So this will be a success, right? Suppose again I succeeded in my second toss, and in a third toss I got a head, a tail, sorry. So I am failed here, right? And in the last one also I failed, that means I got a tail. So what is the maximum number of success I can get here? I can succeed in all of them, right? So the maximum number of success is 4. What is the minimum number of success I can get? I can get tail in all of them, and I can fail, and I can get 0 success, right? So the maximum number of success here means getting a head, right? There are 4 possibilities, right? That means maximum I can get 4 heads because I am tossing 4 coins, and the minimum head I can get is 0 because I can get all of them tail, and the minimum number of success is 0. So binomial distribution, or the formula of binomial distribution, is a way to find out what is the probability that if I repeat a Bernoulli trials n numbers of times. So we will be using the term n to refer to, in this case we are repeating it 4 times, right? So n will be equal to 4. So what is n? N is the number of repetition. So coin tossing is a Bernoulli trial, and we have repeated that trial 4 number of times, right? We have repeated it 4 times. So that's why n is equal to 4 number of repetition. And if the coin is fair, then getting a head and getting a tail will be equal. They will be equally likely. Both of them will have 50-50 chance. So if the coin is fair, you have a 50-50 chance. So P will denote the probability of success. If the coin is fair, it will be half or 50%, right? So P is the probability of getting a head, N is how many times you have tossed the coin, right? Will give you the probability of exactly how many success you will get, right? So if you want, what is the probability that I will get all of them head, right? So in that case, I am interested in probability of 4. That means 4 successes. So I will replace this small x by 4. I will replace the value of n, p and small x by here, and I will get a probability, right? So the formula is n cx p to the power x q to the power n minus x. So what is n? How many times the Bernoulli trial is repeated, right? What is x? The number of success you are interested in, right? What is p? P is the probability of success, right? So if the coin is fair, both of them will have probability of half and half. What if the coin is unfair? It is more likely to get a tail than head, right? In such a case, probability of success will be different. And what is q? Q is nothing but q is equal to 1 minus p. Now q is called probability of failure, the reverse, right? P is called probability of success, q is called probability of failure. So if you place all the values in this formula, you will get probability of x successes, right? Now this formula is called probability mass function. So in very simple word, the formula that is used to find probability of discrete distributions, I am repeating, the formula to find out probability of a discrete distribution is called probability mass function. On the other hand, the formula that is used to find out probability of continuous random variable will be called probability density function, right? So we have probability mass function and probability density function. Probability mass function is associated with discrete distribution, whereas probability density function is associated with continuous distribution, right? So this is the formula or probability mass function of binomial distribution. Now there are certain properties of binomial distribution. First of all, this n, that is number of repetition, and p, probability of success, are called parameters. Every distribution will have its own set of parameters, and these parameters are somehow the characteristics of the distribution. These parameters helps us to identify or distinguish between different types of distribution, right? So n and p are the parameters of binomial distribution. So if a random variable x follows binomial distribution with parameter this n and p, then we write it like this: x follows binomial n comma p, b for binomial, and within brackets we write down the parameters, right? So for example, in a situation there is a random variable called x, right? It follows binomial distribution with certain characteristics, like the Bernoulli trial was repeated 10 times, right? The Bernoulli trial was repeated 10 times, and the probability of success is 1 upon 4, let's say, right? Probability of success. So this will be n equal to 10, p will be 14. So how we will write this? We will write x follows binomial 10 comma 1 upon 4, right? So this is the way we denote a binomial distribution. Now if a random variable x follows binomial distribution, then its mean, arithmetic mean, is given by the multiplication of the two parameters. If you multiply n into p, you will get the average number of successes. Now what is mean? Mean means the average number of successes, and the variance will be given by multiplication of these three quantities, that means n, p and q: number of repetitions, probability of success, and probability of failure, right? Now since the mean is np and variance is npq, now q will always be, since it is a probability, it will always be equal or less than your 1, right? Equal or less than 1. So that's why, so if I have to prove it, let's say q, the probability of success will always be less than or equal to 1, right? Now in ideal situation it cannot be equal to 1, because if the experiment has a probability of failure equal to 1, there is no way we are going to conduct that experiment. But still mathematically it is possible that q will be equal or less than 1. Now if you multiply both sides by np, you will get npq less than equal to np. Now what is npq? Is the variance, right? Less than equal to what is np? Is mean, right? So that's why the mean of binomial distribution is always greater than the variance. It will be always greater than, and at the least it will be equal to the variance. That is one property. Now these properties are useful in practical sense, that when you are going to fit a distribution to a data, it is very advisable that first of all you look into different descriptive statistics of the data, and if you find out that for the particular data set the mean is greater than the variance, then it is very likely that you can apply binomial distribution and it will be fruitful, right? So this is a way to test whether a data set will follow, or can we expect this data set to follow binomial distribution or not, right? So these are the properties. Now let's try some example. The first example of binomial distribution is very straightforward. We are given the parameters n equal to 6 and p equal to 0.4, right? And we are to find out three different probabilities. One is probability of exactly 2 success, one is probability of less than 3 success, one is probability of more than 4 success, right? So let's start. So here the distribution is x follows binomial 6, 0.4. This is the distribution, right? And we are to find out probability of x equal to 2. Number 1 is probability of x equal to 2. This is equal to, what is the formula? NCx p to the power x q to the power n minus x. This was the formula. Here in our case n is equal to 6 and p is equal to 0.4. So what will be q? Q will be equal to 1 minus 0.4, because 1 minus p is equal to 0.6, right? So the formula here will be, we will replace n by 6. C, what is x? X is equal to 2. So 2. What is p? P is equal to 0.4 to the power x. What is x? X is equal to 2. And what is q? Q is 0.6, right? 0.6 to the power n minus x. What is n? N is 6. And what is x? X is 2. So this is the formula to find out the value of exactly 2 successes, right? This is equal to, now what is the formula for NCx? Now NCx is equal to n factorial x factorial n minus x factorial, right? So you will get 6 factorial, 2 factorial and 4 factorial. Why 4 factorial? N minus x is 4. And here 0.4 to the square and 0.6 to the power 4. 6 minus 2, 4. This is equal to, now this will be 6 into 5 divided by 2 and 0.4 square, 0.6 to the power 4. So the ultimate value will be 0.31 approximately. So the probability of getting exactly 2 success in this scenario is 0.31, right? So let's try the second question, which is probability of less than 3 successes, right? So we are to find out the probability of less than 3 success. So probability of x less than 3 will be equal to, now what are the different possible number of successes, right? In this case the experiment was repeated 6 times, right? So what are the possible successes? You can get 0 success, 1 success, 2 success, 3, 4, 5, and the maximum number of success is 6. So we are to find out probability of x less than 3. So what are the possibilities? Less than 3 means 0, 1 and 2. So probability of x less than 3 will be probability of x equal to 0, right, plus probability of x equal to 1, right, plus probability of x equal to 2. Fine. So this is the way we calculate probability if it is given less than a particular value, right? So you will have to individually calculate probability of x equal to 0, probability of x equal to 1 and probability of x equal to 2. Now probability of x equal to 2 we have already calculated in our first problem. Now we have to calculate probability of x equal to 0 and probability of x equal to 1. So what will the probability of x equal to 0? Probability of x equal to 0 will be, what is n? N is 6. C, in this case x will be 0, so 6 is 0. P is 0.4 to the power x, so x is 0, right? And q is 0.6, right, to the power n minus x, so n is 6 minus x is 0, right? So anything C0, so n C0 does not matter what is the value of n, it will always give you 1. So this is a standard value, nc0 is always 1, right? Similarly ncn is also 1. So 6c0 will give you a value of 1 into any value to the power 0 will give you 1, right? Something to the power 0 is again 1 into 6 minus 0 is 6, so 0.6 to the power 6 is the probability of getting exactly 0 success. That means you will never succeed in that particular situation. This is equal to 0.05, approximately 0.05 the value is, right? So we got probability of x equal to 0. The probability of x equal to 1 will be equal to 6c1 because we have to change the value of x. Then 0.4 to the power 1 and 0.6 to the power 6 minus 1, right? So this is equal to 6c1 will give you the value of 6 into 0.4, right, into 0.6 to the power 5, right? So these are the values. If you simplify, you will get a figure, so which is approximately equal to 0.19. So we got probability of exactly 1 success is 0.19, probability of exactly 0 success is equal to 0.05, and probability of exactly 2 success is 0.31. So this is equal to 0.05 plus 0.19 plus 0.31. okay, so 31 and 19 will lead to 50 plus 1, so 0.55 is the required probability, right? So we have done first and second. The third one is probability of x greater than 4. So what are the possibilities of greater than 4? 5 and 6, right? Greater than 4. Now if it was given x greater than equal to 4, then you will have to include 4 also. Now since there is no 4 included in the question, so we will only include 5 and 6, right? So probability of x greater than 4 is equal to, this will be the combination probability of x equal to 5 plus probability of x equal to 6, right? So in the same way, if you calculate the value of probability of x equal to 5, that means replacing here 1 by 5 and replacing here 1 by 5, 1 by 5, you will get the probability of x equal to 5. And similarly for probability of x equal to 6, you will get a value, and you adding them, you will get the value of probability of getting more than 4 successes, right? So this is how we calculate probabilities in terms of binomial distribution. So the next example here is that the random variable x follows binomial distribution with mean 6 and variance 4. So instead of the parameters, here we are given with the mean and variance of the binomial distribution. But we know that for binomial distribution, mean, right, mean is given by NP and variance is given by NPQ, right? So from this relationship, we can obviously calculate the parameters. So the solution will be given that mean is equal to NP is equal to 6, variance is equal to NPQ is equal to 4, right? So let's divide variance. Let us divide this variance divided by mean. This will lead to NPQ divided by NP, right? Which is equal to, what is the value of variance, which is 4, value of mean, which is 6. Now NP and NP will get cancelled, giving us Q, and here we will get 2 by 3 if I cancel this out. So this is 2 by 3. So we got probability of failure 2 upon 3, right? So what will the probability of success? P will be 1 minus Q, right? Which is 1 minus 2 by 3, which is equal to 1 by 3. So we got probability of success as 1 upon 3. And what will be the value of N? You can simply put the value of P in this relationship. So if I put the value of P in this relationship, NP is given as 6. This implies N into P is 1 upon 3 and the value is 6. So if I cross multiply, I get N equal to 6 3 is 18, right? So our N is 18 and our P is 1 upon 3. So our task was to find out the probability mass function of X. So if I know the value of N, if I know the value of P, then it is very easy. The probability mass function is probability of X equal to X is equal to N is 18 C X, right? P is 1 upon 3 to the power X. And what is Q? Q is 2 upon 3. N is 18 minus X. So this is the probability mass function of the required distribution, right? So we have found out the probability mass function. So from given mean and variance, if you are trying to find out the parameters, the first step is to divide the variance by the mean. If you divide the variance by the mean, you will get Q, and towards your right hand side you will get the value of Q. So the next example is, it is given that in a college there are 500 students. 40% students are girl, 10 students are selected at random. Find out the probability of selecting exactly 4 girls. Now in this kind of examples, first of all you will have to set what is your interest, right? So here we are interested in selecting a girl, right? So if you select a girl, that will mean a win for you, that means a success, right? So here X, which is normally used in binomial distribution to represent the event of a success, is selecting a girl, right? So for the solution, we will write solution, let X denote the event of selecting a girl student, right? Now what is the success probability of getting a girl student? What is the probability? So we need, so to calculate or to use binomial distribution, you will obviously need two things. One is N, you need the value of N, and you need the value of P. N is the number of repetition, P is the probability of success. Now number of repetition is obviously, it is given 10 students are selected at random. So you have selected 10 students. So number of repetition will be 10. N is equal to 10 in this example. The only thing that we don't know right now is the probability of success or probability of selecting a girl. So it is said that 40% students are girl, right? So that means if there are 100 students, 40 of them will be girl, and we are interested in selecting a girl. So the favorable cases is 40, total number of cases is 10, so the probability will be 40 upon 100. So here n is equal to 10 and p is equal to 40 upon 100, right, which is equal to 2 by 5. If you simplify, you will get 2 by 5, right? So that means X follows binomial distribution. Why binomial distribution? Because selecting a girl, you can either be successful or failure. So it's a Bernoulli trial, and we are doing the same thing for how many times? 10 times. That means we are repeating a Bernoulli trials n number of times, which leads to binomial distribution. So this random variable, that means X, event of selecting a girl, follows binomial distribution with the parameter 10, 2 upon 5, 2 over, right? This is the distribution, and from this distribution we are interested in getting exactly 4 success. That means probability of X equal to 4. So to get this, we will use the formula. The formula is NCX p to the power x q to the power n minus x. So here n is 10. So 10 c, what is x? X is equal to 4. What is p? P is 2 by 5 to the power 4. And what is q? Q is 1 minus 2 by 5 to the power 10 minus 4. 10 is n, 4 is x. So if you solve this, you will get the value of getting exactly 4 success. Now this will be equal to 0.251. This is the simplification of this calculation, 10c4 to 2 by 5 to the power 4, and this will be 3 by 5 to the power 6, which is equal to 0.251. So the probability of selecting exactly 4 girls out of those 10 randomly selected students is 0.251, which is also equal that you have a 25% chance that you will select 4 girls when you select 10 students randomly, right? So these are some examples of binomial distribution. The next one is Poisson distribution. So if a random variable x follows binomial distribution with the parameter n and p, right? And in somehow the number of repetition is very large, right? You are repeating the Bernoulli trials a very large number of times, and you saw that the probability of success is very low. That means it is approaching 0 and the number of repetition is approaching infinity. Then the ultimate situation reduces to Poisson distribution, right? And remember this relationship. The multiplication n into p is taken as a new form called lambda. This symbol is lambda, right? So n into p is equal to lambda, that is multiplication of the parameters of binomial distribution is taken as a new parameter called lambda. N is very high, p is very low, and that gives us Poisson distribution, right? So a discrete random variable Poisson distribution is again a discrete distribution. So a discrete random variable x is said to follow Poisson distribution if the probability mass function is given by this formula, right? So what is the formula? Probability of exactly x success is e to the power minus lambda, lambda to the power x by x factorial, right? Replacing the value of lambda and x in every situation, you will get a probability. Now, unlike binomial distribution where the number of success is limited, it will be 0 up to n, right? In case of binomial distribution, the number of success, the minimum can be 0, the maximum can be number of repetitions. In case of Poisson distribution, there is no upper limit. The number of success can be anything, because n here is not a fixed value, n is going to infinity. That's why number of success cannot be trimmed, right? So using this formula, we will find out the probability of exactly x successes. Now, what are the properties of Poisson distribution? If a random variable x follows Poisson distribution with parameter lambda, we write it as probability lambda, p lambda. P stands for Poisson, right? Now, in some books or textbook, because p is also used for probability, we write Poisson as it is, right? Poisson lambda, just for the sake of clarity, right? Because p lambda also may mean probability of lambda, right? Now, unlike in case of normal binomial distribution, the mean was mean np, and npq gives us the variance, right? Here, in case of Poisson distribution, both mean and variance are equal to lambda. Mean and variance are equal, and they are equal to lambda. That means in case of Poisson distribution, mean and variance are equal. Now, this property is important from the point of view that if for a data set you are trying to fit Poisson distribution and you saw that the mean and variance are very different, one is very higher than the other, then Poisson distribution may not be very appropriate for that particular data set. If for a data set mean and variance are approximately equal, then you can doubt that this data may follow Poisson distribution. So this is a criteria to find out whether Poisson distribution will be applicable in this data set or not, right? So these are the properties. Let's try some example. First example is very straightforward. You are given that a random variable x follows Poisson distribution with parameter 2. That means lambda is equal to 2. And we are to find out probability of x equal to 3. So probability of x equal to 3 is equal to what is the formula? E to the power minus lambda, lambda to the power x by x factorial. So here e to the power minus lambda, what is lambda? Lambda is 2. 2 to the power x, x is 3 here, right? And 3 factorial. If you simplify this, you will get the probability. Now, in most of the cases, the value of e to the power something is given in the question itself, right? You will be given the value of e to the power anything. If not, you can use any standard calculator and you can find out the value of e to the power minus 2, right? So e to the power minus 2, 2 to the power 3, that means 2 cube will be 8 and 3 factorial will be equal to 6. 6, 8 into e to the power minus 2. Now the value of e to the power minus 2 is 0.135. 135 into 8 divided by 6. So this will give us 0.18. So the probability of getting exactly 2 success here is 0.18, right? So this is first example. The next example is, suppose 2% of the items made by a factory are defective. So in a factory, everything they manufacture, 2% of them are supposed to be defective. Find the probability that there are 3 defective items in a sample of 100 items. So sample of 100 items, that means n is equal to 100, right? Because the defective items here can be either 0 up to 100. So we have the size as 100. Now what is the probability P? Now this is normally, if you see, getting a defective or non-defective is mutually exclusive event, right? So we have n. So this is normally this is a case of binomial distribution because you are getting two mutually exclusive events. But when the number of items, that is n, is very large, and here 2% is the defective ratio, right? So P is equal to 2 by 100. That means the probability of getting a defective item, 2 out of 100, 2% defective, that means you have a probability of 2 over 100, right? Now 2 over 100 is a very negligible value, right? So P is very small and n is very large, right? P is very small and n is very large. So this leads to Poisson distribution. So in this kind of solution, here n is 100, P is equal to 2 by 100. Since n is large and P is very small, we can apply Poisson distribution, right? This is the reason why we are using Poisson distribution in this example. Now we have already stated that in this relationship, see, NP is equal to lambda. If you multiply the value of n and p, you will get the parameter lambda. So here we will get lambda is equal to np, which is equal to, what is n? 100, p is 2 over 100, so lambda is equal to 2, right? So we got that the parameter for the Poisson distribution is 2. So n is number of repetition, p is the probability of success, and if you multiply them, you get the parameter of Poisson distribution lambda, and you got it as 2. And we are interested in getting 3 defective items, right? That means we are interested in probability of x equal to 3 when lambda is equal to 2. Now in this example, we have already calculated when lambda is equal to 2, probability of x equal to 3 is 0.18, and I have already shown the different steps to achieve at this final outcome. So here also probability of x equal to 3 will be 0.18, right? So this is how we calculate probability for Poisson distribution. The next and the last distribution is normal distribution. Now what is the difference between the other two distributions and normal distribution? Normal distribution is a continuous distribution. That means the underlying random variable will be a continuous random variable. So normal distribution is a continuous distribution. A continuous random variable x is said to follow normal distribution with parameter mu and sigma square. Mu is the mean, sigma square is the variance, right? So mu and sigma square, if the probability density function, as I have already stated, for discrete we have probability mass function, for continuous we have probability density function, right? So the formula to find out probability or the probability density function is fx equal to 1 over sigma root twice pi e to the power minus half x minus mu by sigma whole square, right? So this is the probability density function of normal distribution. Now how to denote? We denote it as x follow normal mu sigma square, right? This is the way we denote if a random variable x follows normal distribution. Now there is another distribution that is a subdistribution, or this transformation of normal distribution called standard normal distribution. Now standard normal distribution is very useful in practical applications. That means when you go for calculations of normal distribution, and the standard normal distribution is obtained by the transformation z is equal to x minus mu by sigma. So suppose a random variable x follows normal distribution with parameters mu and sigma square, right? Mu is the mean, sigma square is the variance. Now from the random variable, if you subtract its mean, right? So let's say a practical example. Let's say x follows normal distribution with a mean of, let's say, 10 and a variance of 16, right? Mean is 10, variance is 16. Now if I write x minus, what is the mean? Mean is 10 and 16, and 16 square, 16 is sigma square, so sigma will be root over 16, which is 4. So if I find out a value x minus 10 by 4 and set it to z, or nowadays called g, then this will follow standard normal distribution, right? So if you subtract the mean and divide by the standard deviation, you will get a new data, and those new data or new set of data will follow standard normal distribution. Now what is the advantage of using standard normal distribution? Standard normal distribution has a fixed mean 0 and fixed variance 1, right? So this z will follow, or g follow, normal distribution with parameter 0 and 1. This is fixed. No matter what is the original distribution of x, suppose in some case x follows 10, 16, in some case x may follow an 100, this, right? Then also z will follow n01. So no matter the actual distribution of x, the transformed z or g will always follow normal distribution with mean 0 and variance 1. So this standardized our calculation, right? So that's the advantage of your standard normal distribution is in calculation, right? There are two very important property of normal distribution. There are various properties, but these two are the most important from the point of view of our course. That is, one is mean, median, mode are equal, and the distribution is unimodal. Now when we are calculating mode, I told that a data set can have more than one mode, right? If more than one number is repeating maximum number of time, then we can have more than one mode. But in case of normal distribution, there will be only one mode. This is a hard and fast rule. And the next hard and fast rule is mean, median, mode. Now when we calculated mean, median, mode for a same data set, we never got it equal, right? But in case of normal distribution, mean, median and mode will be exactly equal. So why this property is important? Because this property tells that if for a data set you found out that mean, median, mode are approximately equal, then you can expect that this data set follow normal distribution, right? And the distribution is unimodal. Now if I plot a normal probability density function, if I plot the function this fx in a xy curve, along this there will be value of x, right? Because now x can range from minus infinity to infinity. It can go from minus infinity to infinity, this x. Now if you plot the value of fx in your y-axis, along y-axis, you will get a curve, right? You will get a line. This line is called normal curve, and it looks like this. No matter what are the values of mu and sigma square, the normal curve will always look like this, right? It will always be a very symmetric. By symmetric I mean, if you divide the curve at this point mu, these two lines, this portion and this portion will completely overlap. They are equal and they divide them into 50% and 50%. And at this point, this middle point, you will get the value of mean, median and mode. So the curve is equally divided into two parts by the value of mean, median, mode, right? And they are symmetric bell shape. So this is called normal curve, and this is a division. So density, the midpoint is always mu. Up to this point is mu minus sigma. This is mu plus sigma. This is mu minus 2 sigma. This is mu plus 3 sigma. And this is mu plus 3 sigma. This is mu plus 3 sigma, mu minus 3 sigma. So there are certain properties that I will not go in depth, but roughly 68% or approximately 69% of your data will fall within the range mu minus sigma and mu plus sigma, right? And approximately 99% of your data, 96% of your data will fall within this mu minus 2 sigma and mu plus 2 sigma. So basically this is a structure of the normal curve, right? Normal curve will always look like this, right? This is called a normal curve. Now let's take an example of normal probability calculation. So here, one thing that you should remember, in case of continuous distribution, when your random variable is continuous, we never calculate probability of x equal to an exact value. The probability of an exact value is always 0, right? For a normally distributed random variable, if someone asks you to find out the probability of, let's say probability of x equal to 5 or probability of 5, right? It will always be 0. Probability at a fixed value is always 0. We always calculate probability within a range, right? So the situations are like, say you want to find out the probability of this random variable lying between an interval. Let's say what is the probability that it will lie between 0 and 1? What is the probability that it will be greater than 5? What is the probability that it will be less than 10? Those kind of calculations are done in case of continuous distribution. So here it is given that a random variable x follows normal distribution with mean 5. That means mu is equal to 5. And standard deviation 4. That means sigma is equal to 4. Right? And we are to calculate these three probabilities. Right? The first one is probability of x less than 30. So let's see how we can calculate this. Number 1, probability of x less than 30. This is equal to, in case of calculation for normal probability, we transform, this is in terms of normal distribution, we transform them in terms of standard normal distribution. And how we can do that? We will write probability of x. Now what is the mean? So z, the transformation was z equal to x minus mu by sigma. So we will do the transformation everywhere. So x minus mu. What is mu? Mu is given as 5. And what is sigma? Sigma is given as 4. Right? So we have subtracted the mean and divided by the standard deviation. So if you apply a transformation to your left hand side, the same transformation also applies to your right hand side. Otherwise the inequality not holds. So 13 minus 5 divided by 4. Right? So this is equal to probability of x minus 5 by 4 is the transformation, so we will write it as G. Less than 13 minus 5 is 8, divided by 4 will be 2. So basically we started with x less than 13, we arrived at probability of Z or G less than 2, right? So for solving normal probability problem, we always draw the normal probability curve, right? This is the curve. For standard normal, since standard normal this Z follows normal 0, 1, and in this curve I said that the midpoint is always the mean, and for standard normal mean is 0. So for standard normal, the curve, the middle point will always be 0. This will be minus infinity, this will be plus infinity, right? So that means this point will be 0, right? And we are trying to find out, this is the curve of Z, right? This Z, right? So we are trying to find out a probability of Z less than 2, right? So let's say this is the point 2, right? So we are interested in this area under the curve. So if you can find out the area under this curve, that will be the probability of Z less than 2. So you need this. Now the half or the line this over 0, divide it by half, right? 50%, 50%. And we know total probability is always 1, right? So this is minus infinity, this is plus infinity. So this region will always be half, half means 1 by 2 or 0.5. So if I can calculate this value, I will get, so basically I need the integration of the curve from minus infinity up to 2, right? That means you want to integrate fz from minus infinity to 2. So there are tables that gives you the figure. So there are tables for standard normal distribution that gives you the figure for exact values 1, 2, decimal, etc., etc. By looking at the table, you can find out what will be the value of integrating standard normal distribution from minus infinity up to a particular value. In this case, we are trying to find out. So this is equal to minus infinity to 2 fz dz, and the value of this integration is obtained from something called standard normal table, right? And the value for this particular integration is 0.9772, right? So there will be a table. That table, I will leave a link to that table in the description, right? So this table gives us the value of standard normal figures. So for standard normal integration up to 2, the figure is 0.9772. So before solving the second question, that is probability of x greater than 1, we need to know one property of standard normal integration, that is integration minus infinity to minus, let's say, x fz dz, right, is equal to 1 minus integration minus infinity to x f z dz. So in short, if you want to find out probability of z greater than, or sorry, less than, z less than minus x, right, this is exactly equal to probability of 1 minus probability of z less than x. So negative can be transformed into positive using this relationship, right? So that is one property. So we will be solving the second question, that means probability of x greater than 1. Just like the first one, here also we will transform it into standard normal by subtracting the mean 5 dividing the standard deviation greater than, doing the same treatment to our right hand side also, right? This is equal to probability of J greater than 1 minus 5 is minus 4 divided by 4, so minus 1. So we have to find out this. So this can be written as probability of Z less than 1. It is by symmetry. So this is equal to probability of Z. This is integration minus infinity to 1 fz dz. Now we will get the value of this integration from table, and the value is 0.8413, right? So this is the solution of our second question. And the third question is asking us to find out probability of the random variable within the interval, right? 4 and 9. So probability 4x9. So we will do the same treatment, minus 5 divided by 4, and the same treatment to left and right. Minus 5 divided by 4, 9 minus 5 divided by 4. This is equal to probability 4 minus 5 is minus 1 by 4. This will be Z. This is 1. Right? So this is equal to, so the area that we are trying to find out, this is 0. This is, let's say, minus 1 by 4. This is, let's say, 1. So we are trying to find out the area under this region, right? So this is basically integration minus 1 by 4 to 1 fz dz, which is equal to integration of, or integration minus infinity to 1, right? So how we will get this? If you integrate up to this point and you integrate up to this point, if you subtract this region, this smaller region from this larger region, you will get this area. So this larger region is integration from minus infinity to 1. So integration from minus infinity to 1 fz dz, minus this smaller region is minus infinity to minus 1 by 4 fz dz, right? So minus infinity can be written as 1 minus positive, right? So we will get integration minus infinity to 1 fz dz minus 1 minus integration minus infinity to 1 by 4 fz dz. So we are using this property that we have stated, that negative can be transformed to positive. So this negative and this negative will lead to positive. So this is minus infinity to 1 fz dz plus minus infinity to 1 by 4 is 0.25 fz dz minus 1. Now the integration of minus infinity to 1 fz dz is 0.8413, that we have already found out, right? Plus the integration of minus infinity to 25 that we can get from standard normal table is 0.5987 minus 1. So this gives us 0.44, right? So the probability of the random variable x lying between 4 and 9 is 0.44. So this is how we calculate probabilities of standard normal distribution, right? Using normal distribution using standard normal distribution. So that is all about some standard probability distributions. So we have discussed binomial distribution, we have discussed normal distribution, and we have discussed Poisson distribution, and we have also discussed how to calculate probability under the three different distributions. one thing that you should remember, binomial and Poisson is discrete distribution where normal is continuous distribution, and the calculations of continuous and discrete distribution are completely different, right? So that's all for this one. Here we have concluded the chapter of probability. In the next one we will be discussing about statistical test or testing a hypothesis. That's all for this one. See you in the next